All right, in this video, we are going to look at slope-intercept form, graph, and identify key attributes. So first of all, slope-intercept form is y equals mx plus b. The m is your slope. And the b is your y-intercept. The x-intercept is the point where the function crosses the x-axis, also called a zero. There's other names that we'll talk about later in the year, but for now you need to know it is an x-intercept and also called a zero. Those are interchangeable. They mean the exact same thing. And a y-intercept is where the function crosses the y-axis. Okay, and so we are going to graph each equation and identify these key features: the x-intercept, the y-intercept, the zeros, which is the same thing as x-intercepts, and the slope. Okay, so looking at number one, we get the slope for free by looking at the number next to x. And so in this case, our slope is 2. We also get our y-intercept for free by looking at the term without the x, y equals mx plus b. And so in this case, m is 2 and b is 3. And so when you write the slope, don't write the x with it. That's a habit I see some students write. The slope is a value. We practice calculating slope, and every single time it was a number, it was a value. It didn't have x with it. Okay, for a y-intercept, sometimes they just write the number, but a better way to write it is as an ordered pair. It's when x is 0, and so for a y-intercept, you know it is always going to be in the y position. Okay, and then similarly, the x-intercept is always going to be in the x position. And so we will have either a number right here, or we will have a number, comma, 0. Okay, so we don't get the x-intercept for free from the equation. The only thing we get is the slope and the y-intercept. So just be careful. Some people call the slope the x-intercept because it's next to x. That is not true. You do not get the x-intercept for free by looking at an equation. And so when you're graphing this, start with the y-intercept, which is on the y-axis. Make sure you plot it on the y-axis at 3, and then our slope is 2. And so if your slope is a whole number, go ahead and write it as a fraction. The denominator is 1. And the reason why you want to do that is because the top number is what we call our rise, and the bottom number is what we call our run. And so when I say rise 2, that means go up 2. And then when I say run 1, you're going to go right 1, up and right for positive numbers. Okay, and so up 2, right 1. So from our y-intercept, we're going to go up 2, right 1, and that's going to give us our next point. Up 2, right 1, and that gives us many more points on the line. If we wanted to go down 2, we could go back 1 and still land on the line and be able to complete our graph. The more points, the better. You really only need 2, but when you're graphing by hand, it's best to fill up the graph as much as possible. You'll see why that's so important when we get to systems and inequalities, all that fun stuff. Okay, and so here we can kind of see where the x-intercept is. It's not a whole number, but if I were to guess, I would say about negative 1.5. I'm going to put a question mark because I'm going to show you how to find it exactly. And so to find the exact value of the x-intercept, you take your equation and plug in 0 for y. And so 2x plus 3 equals 0. We're plugging in a 0 for the y because the y coordinate is 0 for an x-intercept. And so we can solve this equation by isolating x. It takes 2 steps. You subtract 3. And then divide by 2. And so we can see our x-intercept is negative 3/2, or in decimal form, negative 1.5, which is exactly what we're seeing on the graph. And so for x-intercepts, you can write them as fractions or decimals. Slopes should always be written as fractions because that's your rise and your run. Okay. For this next example, they are not giving us a plus number, but the number we are given is next to x, and so we know that's our m. And if there's no plus number, you can fill in a plus 0. That's going to be your b value, your y-intercept. And so my y-intercept is 0, or writing it as an ordered pair, 0, 0. And my slope is -3. Okay, so if my y-intercept is 0, so is my x-intercept, because that's where it's crossing the x-axis and the y-axis. And so they're calling it a 0 right now, but that is the same thing as an x-intercept. Don't let that throw you off. They love to go back and forth between calling it a 0 and an x-intercept just to see if you know your vocabulary. And so here I can see it's crossing the x-axis at 0. And so our x-intercept is also 0, 0. If your y-intercept is the origin, so is your x-intercept. Okay, and so now to get some other points, I'm going to rewrite the slope as a fraction, so over 1. And then remember, the top number is your rise. And because it's negative, that means we're going down 3. And then the bottom number is positive, so we're still going to run to the right 1. So down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1. If you wanted to view the negative on the bottom, that would be up 3, left 1, backwards 1. So I could go up 3, left 1, up 3, left 1. So you can account for the negative in either the rise or the run and still get the right answer. You just have to account for it in one or the other, not both. You don't want to treat both as negative because that would cancel out. Okay, and so if you have a positive slope, you should always have an increasing line. Meaning if a person were traveling from left to right on this line, they should be going up the mountain. If you have a negative slope, as a person travels, he should be going down the mountain. That's called decreasing. Okay, so a common mistake is graphing the wrong direction. Okay, looking at number 3, we have a slope of 1/2. And we have a y-intercept of 12. That's all we get for free from the equation. So the slope is 1/2. The y-intercept is 12. And so as an ordered pair, 0, 12. And so let's start there. Graph your y-intercept at 12. And then for our slope, our top number is positive. So we're going to rise, go up 1. And then we're going to run to the right 2, moving in the positive directions for both. And so if I try to do that, I go up 1, right 2, I'm off my graph. And so instead, we could go down 1, back 2. If we account for the negative direction in both the rise and the run, we'll still end up with a positive increasing slope. And so if you're falling off the graph, just go backwards. Just make sure a positive slope is increasing. The person should be climbing as they go from left to right. Okay, and so now I can't see what my 0 is, my x-intercept. Remember, that's the same thing as an x-intercept. I know it's going to be very, very negative. And so because I don't have a graph, I really have to calculate this algebraically by plugging in 0 for y. Remember, it's a x value when y is 0. And so I set my original equation, 1/2 x plus 12 equal to 0, and then I solve. First step, subtract the 12. And so now I have 1/2 x equals -12. And then if you remember from unit 1, to get rid of this 1/2, we want to multiply by the reciprocal. Okay, and so when you multiply by the reciprocal, you flip the fraction, and that cancels out the 1/2. So we're multiplying both sides by 2/1, which would give me -24. And that makes sense looking at my graph. We already decided it was going to be very negative, and so negative 24 makes sense. Okay, looking at this last one, here they don't have a number in front of x, and what I see often is people putting x as the slope. X is not allowed to be the slope. The slope is a number, it is a value, it is not a variable. And so the invisible one that we talked about in Unit 1 is right there in front of the x. And so my slope is 1 whenever you don't see a number in front. And then my y-intercept is negative 8. Don't lose your negatives. Okay, and so slope is 1, y-intercept is negative 8. Starting at the y-intercept on the y-axis at negative 8. A slope of 1 as a fraction, that's just 1 over 1. So we're going to rise 1, run 1 in the positive direction. So up and right. Okay, so up 1, right 1, up 1, right 1. All the way until we fall off the graph. Oh, and that gives us our x-intercept. Okay, and so we can connect. And then we get our x-intercept now. It is 8, 0. Whenever one of your points lands on the x-axis, you get it for free. So 0, we know is an x-intercept. If we write it as an ordered pair, it's an x value when y is 0. Okay, these next examples, they are giving us the graph and we're writing the equation. And so I always start with the y-intercept. In the case of number 5, I see that it's 1. And so I know my equation always has a y equals, I know there's an x, and then since the y-intercept is 1, I'm going to have a plus 1 at the end of my equation. And so now I just need to figure out the slope. Okay, so this is where you can pick 2 points. I've already got 1, and I have the y-intercept. And this is where I'd like to count the rise over the run. And so here I'm rising 2, and I'm running 3. And so remember, it's rise over run. You don't want to flip those. Okay, and so my slope is 2/3. Rise over run. From the y-intercept, we rose 2 and ran 3 to get to our next coordinate point. Okay, and then our x-intercept is not clear. It looks like it's between -1 and -2. So I'm going to go ahead and just say -1.5 for the sake of time. And then you could solve for it algebraically and you would get -3/2. Okay, for this next one, I probably will end up solving for it algebraically. But starting with our equation, I see my b value is +1. So y-intercept is 1. And to get to our slope, I'm going to go to this point here. So it looks like it's going down 3. So -3, right 2. And so remember, if you have a decreasing graph, this person is going down the mountain. I know it's decreasing. So slope is negative. Okay, and so down is negative. Okay, here we were increasing. Slope should be positive. Okay, and so for our x-intercept, well, let's write the equation first. So now that we know the slope is -3/2, don't forget your x, and our y-intercept is +1, we can solve for this algebraically by plugging in 0 for the y. And so I'm going to have -3/2 x plus 1 equal to the 0. We would subtract 1 from both sides. And then when we multiply by the reciprocal, it's still going to be negative so that the negatives cancel, but we're going to have the 2 over the 3. negative 2 over the 3. You got to flip the fraction, but keep the same sign so that they cancel. And so negative 1 times negative 2/3 equals positive 2/3. And that's exactly what it looks like on the graph. We probably would have guessed that. Okay, for these last two, I see my y-intercept is 4. To get to my slope, this looks like a good point. So 1, 2, 3. 1, 2, 3, 4, 5, 6. Let me recount that. 2, 3, 4, 5. So rise 3, run 6. That can be simplified to 1 over 2. And if you rise 1, run 2, you also get to a good point. Rise 1, run 2, you get to other good points. And so the closer the points, the better. So you don't have to simplify your fraction. I just jumped to another point, but that's okay too. Just make sure you simplify your final answer. And so my equation is 1/2 x. Don't forget your y equals, don't forget your x. You will miss it if you type it in without it. And then plus 4. Okay, and so for our x-intercept, it actually is really nice here. It's negative 8. And then for our last one, we have a y-intercept of negative 6. So we're going to have a minus 6 after the x. Then it looks like we have another negative slope. So here's another point. We're going down 1, 2, 3, 4, and running 2. Or you could also notice that you're going down 2, running 1. Negative 4 over 2 simplifies to negative 2 over 1. And so our slope is negative 2. Don't forget your y equals, don't forget your x. Our y-intercept was negative 6. And then we see our x-intercept, which they're calling a 0, is negative 3.